Yeah, hi everyone. So my name is Aurélien Lequartier. I'm a lead user success engineer at Gimpulse. I'm based out of Paris, and today we're going to do a workshop around computer vision using the Gimpulse platform and the Arduino Portenta board. So I will guide you through the whole process of collecting data. And in the project we're going to work on, we're going to try to classify between different objects. So the objects I'm going to classify that I have here is like my amazing Ricoh camera that I really love, and also my pair of headsets. So we're going to take like different samples of images to classify those two. So if you want to participate at the same time during the workshop, I invite you to choose like two different objects you would like to classify, and then we can get started. So you should have received already the GitHub link that we are using for the workshop. So if you haven't done that yet, you can just go to the GitHub link that's in the chat. So which is basically on the Gimpulse repo, and you look for the workshop Dev Summit 2021 Portenta. And so if you've received that before, you've probably already followed all the requirements to be able to do the workshop. So you need, of course, you need the hardware. So in this case, the Arduino Portenta. And then you need to have a couple of tools installed that we are going to use during the workshop. The first one being the Gimpulse CLI that you can download by following the instruction here. The Arduino CLI that will be required as well to flash the firmware. And if you are using Windows as your main operating system, you will also need the Arduino IDE to basically complete the workshop. So it's something you would use at the end to basically deploy back your machine learning model on the Arduino Portenta board. So if we start from the beginning, so the first thing you would do is you go on your Gimpulse account. So you can see here, I'm connected to my Gimpulse demo account. I've got a couple of projects here already, and I'm just going to create a new one for Dev Summit Workshop 2021, and just creating this new project. In our project, we're going to use images. So I select images, and we're going to do single object image classification. Okay, so I've created my project. Now, the first thing we need to do is, so if you've downloaded the GitHub repo, so if you're familiar with GitHub, probably you've cloned the Git repository already. If not, you can just also click on code and download as a zip file. So once you've downloaded the repo, so you've got the complete source code and a couple of scripts. And what we are going to do is, so first you need to connect the board to a USB cable. And we're going to flash the firmware. So if you've already flashed the firmware because you followed the prerequisites before the workshop, I would invite you to flash it one more time, because we did a few changes yesterday in the provided firmware. And so it would be better to flash it again in order to get the latest improvements. And so for that, as you can see, I just went into the flashing scripts from the repo. You've got the firmware, which is here, and then you just double click on the flashing script for your operating system. And so in my case, I click on the one for Mac OS. And so it starts by basically like checking I've got all the different Arduino dependencies that we need to flash the firmware on the Portenta. And then it's basically downloading the firmware on the board. And so now it's been uploaded on the board. And so I can now open a new terminal. and run the edge impulse daemon. Oops. Oh, maybe actually I didn't flash it correctly. Let me try one more time. So you may have like issues during when you flash the firmware. If that's the case, you can like double click on the blue button that you have on the Portenta. You can see one in the middle, which is here. And basically when you double click on this one, what it will do is it will go into bootloader mode. And so you just double click on this, and then you should be able to flash the firmware for the board. Once you manage to flash the firmware, like what we want to do next is to connect your board to your Edge Impulse project, the one we've just created before. And the first command that we are going to use is this Edge Impulse daemon. So I will zoom a bit here. So you just click the Edge Impulse daemon and start. And it will ask you for your Edge Impulse credentials, and then ask you to select a project to connect your board to. So could I go back here and so select the other project that I worked on, which in the case I connected actually some Portenta boards to this one. So once you've launched the Edge Impulse daemon, when you go into your devices section, you will be able to see the Portenta board, which is connected to your Edge Impulse project. So here you should get a green dot. And once you've got that, it means that your board is connected to your project, and you can go to the next step, which is doing the data acquisition. So you see here, like I've collected like a bunch of different data already for this project. But what I would suggest is collecting around 30 images for each object you want to classify. So like for me, I've got, as I said, my camera. So I've collected 30 images for my camera. I've collected 30 images for my headset. And then you collect 30 images of something completely random, which is neither one of the two objects that you want to classify. And to do that, so once you go on this page, so yeah, as I said, unfortunately, I'm having technical issues with my hardware. But on the right side here, you will be able to select your Portenta board and the camera. So you can select the camera, and you've got different resolutions that are available. And I would suggest to use the 320 by 320 pixels resolution. And from there, you can start collecting data. So you will need to select a label. So like I can show you like some of the pictures I've took for this. So like you can see here on the right side, the photos of my headset. So like with different zoom, different angles, so it had some diversity to the model by doing that. So you select, you just put a label for the object you want to classify. So in this case, headset, you do the same thing for the other object, and the other one, which you can call like random or unknown. And so you do that roughly 30 times for each object. So it may take like a couple of minutes for you to be to collect the data set, but once you've collected the images, so if we imagine that you've got 30 images for each class, you've got 2 classes plus the random one, you will end up with around 90 or like 100 images. And once you will have collected all the data, you will see that all the data will be basically in your train set, in the training set. And what we want to do is to take part of this data as our test set in order to verify that the models that we will train will also work on different data. And so the way you will want to do that once you've collected the data is go to the dashboard. And if you go at the end of the page, you will see like the danger zone here. And you can click on perform train test split. And by doing that, it will roughly split your data set into 80% in the training and 20% in the testing set. So I'm going to pause a bit here, see if we have any other question. And maybe in the meantime, I can try actually a different cable for my board.
We have one question from Matthias. I don't know if we can unmute Matthias.
Oh yeah, I was like messing around yesterday, and I've actually took an image of 3 different objects, and so now I wanted to know whether I can connect my board to a new project, or if I should work with the one I've already gathered some samples on.
Yeah,
Thing is,
yeah.
I've also collected samples with my mobile phone camera, so I'm not sure if that kind of messes with the algorithm that detects those objects, because it has different resolutions and color imaging and stuff like that.
Yeah, so it's a good question. So regarding your first question on the images you've already collected, so if you just have a few, like I would suggest you can just delete them. Like you said, you have maybe 3, so you can just click on each and delete. Or you can also go into the dashboard, and at the end you can also click on delete all data in this project, so it would just delete the whole data set basically. But if you want to connect it to another project, which is actually something fairly usual to do, basically what you need to do is to add a different argument to the edge import CLI. So I can actually show you that. So if I open like a terminal, and when you run the edge imports daemon, you can add this clean flag. And so it will ask you again for your credentials and ask you to select a project. So in this way, you can switch projects easily to connect your board to.
All right, thanks.
And you had a second question, and I forgot.
Yeah, it was about, well, I've already taken like 150 images.
Or with
And
a
some
phone.
of them, yeah, I've also collected some of them with my mobile phone. So I wanted to know whether that messes with the algorithm, or if I could still use those images.
Yeah, so you can still use those data. It's like it's not an issue. Like probably what you will notice is, like, for instance, here, if I look at the pictures I took here with the Portenta, like the length is probably not the same between your smartphone and the Portenta. So maybe you've got like a wider angle on your smartphone, or the other way around. So you will get some differences in the images, but in the end, for the neural network training, it's not going to be an issue. As long as you have some diversity in your data set, it's completely possible to collect data with different devices and your smartphone.
Okay, perfect. Thanks. So I will work with the other project then.
Perfect.
Thanks.
Yeah. Do we have any other questions? I just wanted to pause for a few minutes so people can have time to collect the data using the Portenta. No other question? Okay. I guess maybe we can go to the next step then. So if you haven't had time to collect enough data, that's fine as well. Like, it's still something you can add later on and retrain your model. And it's actually like a good a good exercise to see, like, if you have, when you add images to your data set, do you have like accuracy improving for your machine learning model? Okay, so once you've collected your data, as I said, like, you would like to, usually, like, it's better to keep part of the data set as the test set. So you can go to the dashboard and slide at the end of the window and click on the perform train and test split. And so you will get 80% in the training and 20% in the test set. Okay, and so then once we've created our data set, the next step is to basically like create our machine learning model. And so for that, so you will see that like the first block on the left, the image data will be already pre-populated because we've detected that we are working with images. If you were working with sound, this would be a different block here. If it was with sensors data, it would be different as well. And so we're just going to keep the default parameter for the image data. Then for the next block, so you can click on add a processing block. And from there, you just select the first one, which is the image block. And so if you're interested to know more about the blocks we have here, so we've got like good descriptions in our documentation. The code behind that is also available publicly on GitHub. And so we've got like blocks for different type of sensors. So we've got the one for image that we are going to use. We've got some for audio, if you want to do keyword spotting, for instance, or if you want to detect any non-voice audio. We've got the spectral analysis, which is very useful if you are working with sensors such as like accelerometers and so on. And you can also add your own custom block. So like if you have your own signal processing algorithm, it's also something you can add to the platform. All right. So you add the image block here. And then for the next one, for the learning block, you select the transfer learning block for this particular project. So we can also do like regression, anomaly detections. For instance, if we're working with sensors, we've got also like the regular classification where you can create your own neural network architecture. Here for images, we use a technique which is called transfer learning. And what we do with transfer learning is we use like an existing architecture, which is Mobilenet v2, and then we fine-tune it by retraining the neural network with the images we have in our data set. And by using this transfer learning technique, it allows us to build a machine learning model with just a very few data. So with just tens of images, you can build an image classification model with fairly good accuracy. If you were working with like a classy neural network and you would define your own architecture, you would need to get more data in your data set to get the same performances. So you add these two blocks and then you save the impulse here. And then we can go to the image block, which is here. And in this particular one, like you've got only one parameter to select, which is, do you want to use RGB or grayscale? The Portenta board, it has an high-max camera, which is actually grayscale. So for this one, we're going to use grayscale. And regarding the question from Matthijs previously about like collecting data with different devices. So like, for instance, if you use your smartphone, probably you will collect images in RGB. And so here it's important to select grayscale. So like all images will have the same color depth. So you select grayscale and save the parameter. And then from here, you can generate features for the data set that you have collected. And so once you generate the feature, so it takes a couple of seconds, it should take less than a minute with like 100 images in your data set. You will see on the right side, basically the features that have been generated for your data set with a specific color for each class you want to classify. And so in my case, I've got like in blue, that's my camera, and I can click on each of them individually. In orange, that's the headset samples. And in green, that's basically like random images I took. And so this can be like fairly useful, like in particular also when you do like speech recognition, or if you are working with sensors such as like accelerometers to detect movement, like you can see like some distinct clusters in the feature generation, and it can help to detect if you've done some like mislabeling during the data collection. So it's like a very useful 3D view here in the Feature Explorer. And so once you've generated the features, we go into the transfer learning. And in the transfer learning block, so we've got the number of training cycles that we can tune. We've got the learning rate, data augmentation. So it's something that you can enable. So the data augmentation, what it does, it basically do some modification to the images you have. So it's going to mirror the images and transform them in order to add some redundancy to your data set. And that's something very useful, especially like if you want to avoid overfitting. So one problem you can have with machine learning, it's called overfitting, which basically like your model will perform like extremely well on the data you collected, but then if you run the model on the target and you have like images which are like very different or different from the data you have in your data set, it will not perform really well. So it's important to get to avoid overfitting. And one way to do that is using data augmentation. Another way to avoid overfitting is also by adding more data and more diversity in your data set. So you can keep the default parameters here with the number of training cycles set to 20, the learning rate here. And then the next step is to select the Mobilenet architecture. So you can actually select the default one, which is in the transfer learning block. But just to say a few words about the different models. So if you click on choose a different model, you will be able to select like different ones depending on the memory and the flash you have available on your device. So if you have like a device like with fairly small memory, what you can do is select one of the Mobilenet V1. So typically like this one is like the smallest one. And as you can see, it's just using like 50K of RAM, 100K of flash. So that's fairly small. The one we are using here by default is like the Mobilenet V2. And so it's using more RAM and flash, but the Arduino Portenta got lots of memory. So it's better to use this one compared to the Mobilenet V1. And so once you've just selected the Mobilenet V2 035, you enable the data augmentation, then you can start training your machine learning model. Have any other questions? I think Yaya was asking a question.
Yeah. I have a few questions, please.
Mhm.
Yeah. First one, do you have expert mode for also Arduino Portenta?
Mm, by expert mode, do you mean for
Modifying the model, for example, in Keras?
yeah, it's something you can do here in the project. So when so it's still training, but I can switch to it. So if you click here on this button, you can switch to the Keras mode. And here I have access to the definition of the architecture we have. So it's basically Python. So like underneath, as you've noticed, we are using TensorFlow and Keras to train the machine learning models. And so you can just modify your model here directly. You can also have like more information about the data augmentation that we are performing during the training, which is basically here in those few lines. So it's quite easy to switch between the two. So you can do it here. You can also do it if you are using like the classic, like the usual like classification mode, where you could like select like a dense network or a convolutional one.
And also, is each impulse going to handle the, let's say, optimizing the model to be suitable for a microcontroller? I mean, the part of TensorFlow Lite Micro. Is it handled from also the same place?
Yeah, that's a good question. So, I mean, it's something I will explain a bit later when we go to the deployment. But we've got you've got basically like two options to deploy to your device. So once we've trained the model, we can either create like a binary for the boards that are officially supported, or we can also create a C++ or Arduino library with the source code completely available to the users. And so you've got two options. One is using TF Lite micro interpreter. And the other option is using our own compiler, which is called Eon. And so if you use like our own compiler, you will see that it will like drastically reduce the amount of RAM and flash required for the model. And the reason is like if you use like TF Lite micro, it's an interpreter and it's going to load like all the different TensorFlow kernels and operations. And so it's not going to be as optimized in size. What we do with the Eon compiler is that we take the neural network architectures that we have defined, and we compile down to C++ only the like the layers, the kernels and operations we need to run on the target. And for both, you will get access to the source code once you export as a library.
But Eon, does Eon use the same, let's say, same platform of TensorFlow Lite Micro, or it's a different framework?
Yeah, it's slightly different. So you will see that like the files that are generated are different between the TF Lite micro and the Eon compiler. Oops. But I think I lost my screen now. But yeah, what I was saying is once you select the Eon compiler, it will be deployed as a C++ library, but we are also relying on TF Lite to create our C++ library using the Eon compiler.
Can I ask last question?
Sure.
For Feature Explorer, do you have like a reference or something for it? I find it useful, but I have like some technical question. For example, if I have in my image the two classes, I may see from the Feature Explorer that I have like not well separated data. So can I use this feature to like see if my data set is good or not in this case, that my image have multiple classes inside?
Yeah, so it's something you can do. Like the feature explorer we have, it's not like we don't provide the source code, but what we use underneath to get like this 3D view, it's called a UMAP. So it's like dimension reduction algorithm that you can use to go from like a very high dimension data to a 3D dimension. So it's using the UMAP. But what you could also like just do is like import your data set and then check into your Edge Impulse project in the Feature Explorer how it is performing.
Thank you very much.
Sure. Checking if there's any other questions. I think it's good so far. I think Roland is raising his hand.
Hello.
Hi.
Sorry. Great presentation so far. I was muted, so I was talking to myself here.
No worries.
Just a quick question about the IDE. Like, do you have a source code available in STM32 IDE, or is only for Arduino IDE purposes for this particular one?
Yeah, that's a good question. So like for this particular workshop that we are doing with the Arduino Portenta, it's only for the Arduino using the Arduino IDE. But like we also support like STM32 CubeMX projects. So when you create your project, you can also export your project as a STM32 CubeMX. So it's also something that is supported.
So, so as far as API, is there any, available API that we can export into STM32 and just run it? Like, I'm just guessing, like, how long will it take to port this example into a different IDE?
Oh yeah, that's a good point, because like for the Arduino Portenta, we use embed underneath.
Yeah.
So if you would like to use the same Portenta using STM32, yeah, you would need to do some work to port the firmware for this one. I'm not sure exactly how long, but yeah, that would be a bit of work. What you could do though is, if you are interested, I can actually show you here in the documentation. So in the documentation, you can see like the different boards we support.
Yeah.
We'll zoom a bit. And then you've got these tutorials about running your imports locally, which is here. And you've got one specific for running the imports on STM32. And so you can click on that, and it will guide you through like how to build like a simple project to start with. And so you just, like, as I was mentioning, once you deploy your project, you can select STM32, and then you need to do some configuration into the IDE. So it's something you could actually try if you're very familiar with STM32 and the Portenta hardware, and see how it works.
All right, thank you. I'm using STM32 hardware and trying to do the same thing before. But yeah, I was just curious.
Sounds good.
This hardware can be used. Yeah. Thank you so much.
Thank you. All right. Going back to our Edge Impulse project. So once basically you finish training your model. Like the next step you can do is going into the model testing. And as I was saying before, like you usually want to keep like a part of your data set as a test set. So that's what we were doing, going into the dashboard and splitting between train and test. And here you can see how it performs. And so just click on classify all to classify the different samples I've collected in the test set. So it's take a bit of time. And you can see here at the end, we've got like 88% accuracy, which is actually fairly close to what we had during training. I think we had like 86 or 87. And you can have like the details for each class. So like camera is at 85, headset as well, and the random class is at 100%. Let's go back actually quickly on the transfer learning because I didn't talk much here about this. So we can see we've got 87% for the training performance. I can see that, like, for instance, my camera performance is not really good. Like I've got like perfect accuracy for the headset and unknown class, but the camera itself is a bit low. And here in the confusion matrix, the way you read it is like you can see here for each camera samples we've trained, some of them has been detected as unknown. So this is part of the validation set during training. So the reason for that, it could be that when I collected this random class, I took pictures very randomly, and some of them may be very similar to the one I took for the headset. And so if I want to fix that, what I would do is probably like take a bit more samples in order to improve the accuracy. But overall, the 87% accuracy with just few tens of images is quite good already. So as I was saying, the model testing, we've got 88%, which is quite good. And yeah, the last step here is going into the deployment. Before going into the deployment, like one quick word about the versioning. So this is something that is interesting, especially if you start with an existing data set and you want to add data over time to improve your machine learning model. What you can do is you can use a versioning to basically take a snapshot of your project at a certain time. And so you can just store your current project version, and it will store like all the configuration you've done in your project, as well as the data set. So you can get a snapshot of your data set and later on add more data, see if it works or if it doesn't. And so if you're having worse results by collecting new data or by changing your machine learning model, you can still go back to the previous version by loading the snapshot you took here. Okay. And then here, the next step is the deployment. So something I've mentioned a bit already with the question we had. So you can you've got two types of deployment you can create. One is creating a library. So you can create like a C++ library, which has like no specific dependencies. So as long as you have like a modern C++ compiler, which is C++ v11, you will be able to compile the project. So just need like a modern compiler for it. We've got also some optimization underneath for, well, in our case here, for instance, with the Portenta, like to leverage like the CMSIS, the Arm CMSIS DSP, and CMSIS NN instructions in order to get the inference running on target faster. But you can also like just run it and compile it on your PC, for instance. So we've got the Arduino library. So in this particular case, that's what we are going to select for our project. We've got the CubeMX export for the STM32 pack. The WebAssembly, which is more for web development. So it's like a nice package that wraps around JavaScript. So if you want to run your model on a web page, that would be like the good output. We got the TensorRT library for the NVIDIA Jetson. And then we've got the firmware, the binary firmware that you can just use directly on your target. So that's basically like the quickest way to go, because you don't need to do any firmware development in order to use this binary firmware. So you just select one of the board that is here, click on build, and then you will get a binary that you can flash directly on the board, and then you use the edge import CLI to run the inferencing on the target. But in our case, we used the Arduino library. So I select the Arduino library. We had a question before, forgot who was asking the question about the TF Lite Micro and Eon, but this is what you can select here, basically. So if you disable Eon compiler, you can see like the flash usage for the quantized neural network is 765. If I enable Eon, you've got to 585. So you can see like some drastic reduction in RAM and flash usage using Eon compiler. I see there's a question from Rodrigo regarding the GitHub code, if it's just for the Portenta H7. So yes, the GitHub code that we have provided for the workshop is only going to work for the Portenta H7. Also, in the next couple of weeks, you will also have here an option to select like a binary firmware for the Portenta H7. Okay. So in our case, regarding the optimization, we just select the Eon compiler. We also use the neural network quantized version. So it's not something I've talked about, but when you do the training, we can do post-training quantization, where basically you can select if the neural network weights and activations are using the default float 32, or if you are using 8 bits quantization. So in some cases, you can have better performances, better accuracy with the unoptimized one, with the float 32. Here in our case, we've got actually like exactly the same accuracy. But the benefit of using the quantized version is that it takes less space in memory, and the latency is also much better using the quantized. So we are going to select the quantized and build the Arduino library. So if you've already trained your model, you can go into the deployment, select the Arduino library, and just click on build. Okay. So now that we've got the Arduino library that has been exported, so you can just open it. Trying to find it on my Mac. And so basically you will get this, that will be the different folders here that will be created. And what we want to do is go into here the SRC folder And we are going to copy paste the 3 directories from that we originally have in the GitHub repo. So if you go in the workshop dev summit Portenta, which is a code exported from GitHub, you double click on SRC. And from there, you can actually, just to be safe, you can delete the 3 directories, which are Edge Impulse SDK, model parameters, and TF Lite model. So I can remove the 3. And then I will just copy paste those 3 directories. I could also copy like the Portenta header file. It's not going to affect compiling the model. And so now we've got a new source code with the model we've just trained. And so once we've done that, so for users on macOS, you can just go into the main repo, do run Arduino build, and with the build option, and start. And so here it's using the Arduino CLI to basically build the model here. If you are using Windows, so you can, if you go back to the GitHub repo in the requirements, you have to add like 2 files to like a specific location in the Arduino embed Portenta directories. So that's the file boardlocal.txt and platformlocal.txt that you have in the repository that are here. And so you need to copy them basically in the directory where Arduino is installed. So I can show you quickly where it is located. So if you want to know like in which directory you have to copy that, you need to look for, if you open the Arduino menu preferences, you will see a link for the location of the preferences.txt file. On my MacBook, it's here. On Windows, it will be something different, and same thing for Linux. So like, for instance, if I open my Arduino and I look into preferences, you can see that it's being copied here in this directory. And then, so you can open this directory on in your file explorer and look for the Arduino hardware embed Portenta and 252, which is the version of embed that is being used for the firmware. And this is in this directory that you need to copy the 2 files. And then from there, you will be able to compile the firmware using the IDE. So it's not only for Windows, but it's also for macOS users and with Linux users. There's a question from Jürgen.
Yeah, actually, I had difficulties. Logging into the workshop, so I just joined 10 minutes ago. Is this getting recorded?
Yes, Jürgen, it will be recorded and should be available in a couple of days, hopefully.
Okay, yeah, the link didn't work. I mean, it was a bit of a mess, actually. Okay, thanks.
Can you see the link in the chat for the GitHub repository?
I think Jürgen meant the link for the call didn't work, not the.
Oh yeah. Oh yeah.
Yeah, the Zoom didn't work. It asked me for a non-existing password which wasn't sent out.
Okay.
And then I ended up using a different computer, and there it worked. I don't know why. Okay,
sounds good.
Thanks.
Mark,
apologies, Jürgen. That was a technical issue on our side. So very sorry about that.
Hi, yeah, this is Mark. Yeah, when I run the Edge Impulse daemon, I actually get an error about some JavaScript bindings. I'm assuming I've installed Node incorrectly somehow, but
Yeah, this bindings is usually some error you could get from when you install the CLI. One thing you can try is, let me send you that in the chat. So it's basically like reinstalling the CLI and see if it works. Like it's something that usually works when you're having this issue. If not, you can look more into our documentation. In the link, you've got some troubleshooting section. And if you're still having issue, feel free to go on the Edge Impulse forum, so on forum.edgeimpulse.com, and we will get people from the team helping you through.
Okay. I used just out of curiosity, I did use brew to install Node. Should I have maybe done it from the package from the Node site or something?
I think it should be fine.
Okay.
Yeah, it shouldn't be an issue using brew. Yeah.
Thank you.
Sure. Okay, so while we are answering question, like the firmware has finished building here. So it takes a few minutes. If you're using the IDE, it may take a bit more time, and it also depends on the machine you're running the CLI. So now it's finished building. So the firmware has been generated. Like if I look in my file system, you can see I've got this workshop Portenta bin. And so, as I said, I had issue with my hardware, but I can see if I can flash this way my board. And we will see. And so if you're using the Arduino IDE, it's a bit different. So you need to click on this icon, which says like upload. And first you need to select the Arduino Portenta in the board selection, and then it will go through. Okay, so I've actually managed to transfer the firmware. So it looks like my board is not actually dead. And so once you've done that, it's basically like the end, and it's time to run the model on target. So here we're not using the daemon, but we are using Edge Impulse run impulse. And start that, and we will see. Yeah, so you see like I've got my Portenta. So now it's just facing my laptop, so it's detecting unknown. If I point it out to my headset, you can see it's detecting my headset now. And if I point it out to my camera, you can see that here it's detecting the camera when I'm pointing the camera to. So hopefully it's something you've managed to go through. And if you haven't had time to go through during the workshop, the recording will be available in the next few days. And so yeah, like a few words here on the Edge Impulse run impulse. So like the command I'm using right now, it's underneath. We've got basically like 80 commands that we have implemented like on the firmware, and the Edge Impulse run impulse is sending the AT command to the board to start the inferencing. And from there, you actually don't need any internet connection to run the machine learning model on your device. So this is using basically like the firmware that we are working on at Edge Impulse that will be soon available as a binary on the platform. And then if you are interested in writing your own firmware because you want to wrap around your own application, then it's something you can do as well. If you go back to like the directory of the firmware, so you've got the main Arduino sketch that is here, and if you open it, you will see that underneath it's going to call like some edge impulse function, which you will find here in the src directory. And so if you want to add your own logic to the project, so for instance, like if when you take a picture of a headset, you want the LED to blink red, and if it's another object, you want it to blink a different way, you can add your own logic here in the main.cpp file. The Portenta board, so depending on the shields you have, so one shield has an Ethernet connection, another one has a LoRa connection, and so you can also, what you can do is, so like Jan, our CTO, did a project some time ago with the Portenta where the classification results were sent over the LoRaWAN network. So it's something you can also do if you have the LoRaWAN shield with the Portenta. Can take a couple of questions. So got a question about the subscription. So you can create like your account on Edge Impulse for free. So the platform is free for developers, and then we've got an enterprise subscription plan if you want to access more advanced features, or like if you want to work with bigger data sets, and if you need some more compute time. So like if you're working with big data set, for the free users, we've got a limit of 20 minutes compute time. So when you are doing like the features generation or the neural network training, if it's taking more than 20 minutes, the training will stop. And so to bypass that, you can also upgrade to the enterprise features. And the enterprise features got also more like collaboration features, so you can have multiple people working on the same project. And we've got also like a very complete data pre-processing feature that you can use to basically like clean out the data that you will import, because like in many cases when you work on big machine learning projects, you will get data from different users, different team. You will get like file formats that are different, and usually you will need to clean out the data to select only like the data you want to import to your project, and it's something you can do through the enterprise features. But you can get more details on the differences between the free plan and the enterprise plan if you go on the website. So on edgeimpulse.com, then you go into the solutions menu, and you will be able to see like this table to compare the features between the two.
I think we all have a new question from Yaha as well.
Yeah.
Yeah, I was looking at the inference time for the running model, and it's around 150 milliseconds. But from the training results, it was around, I think, 800 milliseconds or something. So how it's calculated in that training, and is it like an average number or?
Yeah, that's a good question. So actually, if I go back to my project, so something I need to check. So if you go into dashboard, you will see that on the right side, you've got some like project info, and you've got here this like latency calculation where you can select like the board that you want to use for the latency calculations. So as I was saying, like we are going to add the Arduino Portenta like as a binary output in the deployment like in the next few weeks. And so once we'll have that, so we'll have like the full support with the binary output in the Edge Impulse Studio. And so in the latency calculation, you will be able to select select the Arduino Portenta. But basically, like depending on the board you select here, it's going to affect the the latency calculations, because like we simulate the type of hardware in order to get like estimation of memory and latency. So that's why here it's not, we've got something different between what's running on target and what we have in the project.
And also I have a question for object detection. Is it now supported also the same way of image classification, or yet not yet?
Yeah, yeah, that's a really good question. So object detection, like at the moment, is supported on Linux-based devices or on the Raspberry Pi, the Jetson Nano, but we are going to add the object detection on the Arduino Portenta, because it's such a big, it is a board like with a lot of computing power. And so it's something we will add very soon for the Portenta too.
Nice, nice. Thank you.
Sure. Okay.
I also I see Matthias is having some problems in chat. He's getting a missing include file.
Yeah, I think I fixed it now. I somehow managed to not copy all of the folders to my Arduino project, so it's built
Okay.
now. Sorry for that.
Oh, no worries. Yeah. Oh, it's great that you've been already so far. So like how many images did you capture for your model?
I have just a bit more than 150, and I'm getting similar accuracy as you do. So I'm
Okay.
curious how it's going to work out now.
Yeah. Oh, that's cool. Well, yeah, I'm glad that we've got some people who managed to go through the end, and that I managed to fix my board too. So yeah, I think I've been through pretty much all of it. Oh, maybe one last thing, that as we have like a few minutes left, something I haven't mentioned while explaining the workflow is, so we have this new feature, Eon Tuner. So it's actually not that new because it was available for audio projects for the past several months. And 2 weeks ago, we've added the support for also for like images and sensors data. And so basically like the Eon Tuner is like a very great like auto ML feature where it's going to try out different signal processing block, different neural network architecture and parameters to find the one that will get the best performances for your data set. And so it's like very easy to configure. So you just go into configure target. So here we've got an image project. So we just select the classify image dataset category. What is your target device? You can also add like what are the latency that you are expecting on the target, save, and then it will try out different models in the background. And so you don't even need to tune the different signal processing and neural network architecture. So it's like something very, very useful. Like if you are working with sensors or even with audio, like if what you are doing is not like keyword spotting, but trying to detect some specific sound or specific noise, sometimes you will need to fine tune the signal processing, and you may need to try out different neural network architecture. So like the Eon Tuner is like a great shortcut. So you don't need to do that manually yourself, and just use the Eon Tuner to look for the best parameters for your use case. Yeah, okay. So yeah, I still have my project running. And yeah, it's working quite well. Thank you, everyone.